In this video, we're setting up persistent storage for a Kubernetes cluster using a storage class. If you're running a Kubernetes cluster and you plan to deploy stateful applications like Nextcloud, databases, or other services that need persistent data, having storage configured is an important step. In this walkthrough, we're working from the storage configuration in the AWS K8s lab repository, and we're focusing on the local path provisioner approach. The basic idea is simple. Kubernetes needs a way to dynamically provision persistent volumes when an application requests storage. A storage class provides that mechanism. Here, the documentation shows two approaches. The first is a local path provisioner, which is a simple option for a home lab or a small Kubernetes environment. The second option shown is NFS, which can provide shared storage and is more appropriate when workloads may move between nodes. For this walkthrough, we're going with the local path option. Local path provisioner creates persistent storage using disk space available on the worker nodes. That makes it relatively simple to set up, especially in a lab environment where we don't need a separate storage appliance. The first step is to apply the local path storage manifest. The deployment creates the resources required by the provisioner, including its namespace, service account, RBAC permissions, deployment, storage class, and configuration. Once those resources are created, the script waits for the local path provisioner pod to become ready. This is an important part of automation. We don't want to immediately continue and assume the provisioner is ready. We wait for Kubernetes to report that the pod has reached the expected condition. After the provisioner is ready, the script sets the local path storage class as the default storage class for the cluster. That means applications that request persistent storage without explicitly specifying a storage class can use this default provisioner. Now, before running the setup, there's an important troubleshooting moment in the video. With kubectl get storage class returns no resources found. That result makes sense because the storage class has not been created yet. The command is simply showing us the current state of the cluster. So instead of treating that as a failure, we move into the storage class setup directory and run the local path provisioner script. The script begins by displaying that it is setting up local path storage. Then Kubernetes starts creating the required resources. You can see the local path storage namespace being created, followed by the service account and the RBAC resources used by the provisioner. The deployment is created as well, along with the local path storage class and its configuration. At this point, the provisioner still needs time to start, so the script waits. Eventually, Kubernetes reports that the local path provisioner pod has met its required condition. That tells us the provisioner is now running and ready to handle storage provisioning requests. Next step is setting the storage class as the default. The script patches the local path storage class with the Kubernetes default class annotation. After that, the script performs the final verification. We can see the storage class named local path using the Rancher local path provisioner. The reclaim policy is delete. The volume binding mode is wait for first consumer, and volume expansion is not enabled in this configuration. The important part is that the storage class now exists, and Kubernetes can use it for persistent storage requests. The final message confirms that the local path provisioner is ready. So, in just a few steps, we've gone from a cluster with no storage class to a cluster with a working default local storage provisioner. This gives us the storage foundation we need before deploying stateful workloads, and that's the key takeaway. Kubernetes can manage the application, but stateful applications also need a reliable storage strategy. For a simple lab, local path storage is an easy place to start. For a production or multi-node environment, you would want to carefully evaluate shared storage, backup availability, and data protection requirements. That completes this storage class setup walkthrough. If you're building a Kubernetes lab step by step, this is an important layer to have in place before moving on to stateful applications. Subscribe to Tech Shorts for more hands-on Kubernetes, AWS, Terraform, DevOps, and cloud infrastructure walkthroughs.